Hi everyone, welcome to this brand new lesson, and today we are going to cover how to detect outliers in machine learning. Just wanted to show you an example here. We have a figure. Let's say we want to predict here a cluster of the data set. We can clearly see that there are two clusters in this data. There is one cluster and there is another cluster. And after these clusters, there are some data points, and these data points, we get confused whether we want to include these data points in this cluster or in this cluster. Though we can include this in the same cluster, but still these data points are away from the density of these clusters. So these points, we can say that these are the outliers. And the bigger this circle means that the probability of being outlier for this particular data point is high. These are some important data points which we need to look, like where to handle the outliers, why we need to handle these outliers, and how to handle these outliers. It is not always advisable to handle the outliers because sometimes outliers may represent the feature set of the data. For example, let's see if we take these two examples, and in these two examples, let's say one example is a fuel monitoring machine learning model, which monitors a fuel of a vehicle. In that, whether we want to remove these outliers or not, then definitely we need to remove the outliers, because sometimes the data points could be the false representing of the something. And thereafter there is another one, like the fraud detection in credit card transaction. Do we need to remove the outliers in fraud detection credit card transaction? No. We need to keep the outliers because those outliers are most important in fraud detection in the credit card transaction. So in one sentence, it is not always recommended to remove the data points, which is outliers, and it is always also not recommended to keep the outliers in the data points. It depends case based on case, that's mean project to project. All right. So why we need to handle it? Machine learning algorithms are quite sensitive to the outliers, as we have shown here in the above examples. And some tree-based algorithms are not quite sensitive to the outliers. But in general, machine learning algorithms are quite sensitive to the outliers. Recently, it is also proved that even the deep learning models are also quite sensitive to the outliers. But still, the deep learning models perform better than the classical machine learning algorithms. Now, the question comes, how to handle these outliers? We are going to handle these outliers by analyzing the distribution of the variable. Here I have shown you a distribution of a variable. We will be using two types of the distribution. One is the normal distribution and another one is skewed distribution. A normal distribution gets represented something like this, where we get a peak at the mean and then there is a belly shape which get decreased. Alright, in the skewed distribution, we get either the left skewed or a right skewed model. Alright, so we'll be doing some kind of these analysis to analyze the outliers. Now let's say what is this? This one we have represented in the 4 quantile. Here, although it is represented only the 3 quantile, it's like this. This data, that's mean these data are the Q1. So this boundary is a Q1, that's the quantile 1. This boundary is a Q2. And the Q1 means we say that if we sort our data points and the 25% of the data comes something like this. All right. And thereafter the Q2 is also known as the median of the data. So when you plot the distribution of the data, you get the median of the data, which is at the Q2. And if the data is normally distributed, then the median and the mean will be same there. Thereafter, we get there the Q3. So the Q3 is the 75% of the data. So first 25% is the Q1, thereafter the 50% is the Q2, 75% is the Q3, and thereafter the 75% to the 100% of the data is known as a Q4. And the data which belongs in between the Q1 and the Q3, it is known as this data point. That's mean these middle 25% to the 75%, because you add these three. So this data is known as the quantile range. All right, interquantile range. All right, so we'll be doing our analysis of the outliers by the distribution of the variables, and there is a particular method name which is known as extreme value analysis. In extreme value analysis, we have the two options. In the first option, if the data is normally distributed, then we get the outliers by seeing that if a particular data points are after the 3 times of the mean, which is here, are before the 3 times of the mean, after this mean. So this is the variance. All right, 3 times of the variance here and there. So these minus 3 sigma to plus 3 sigma. This is actual data points. All right, and the data points which belongs to the outside of these box, those are the outliers. That is in the case of normal distribution. And if the data point is not normally distributed, then we have here these equation for a skewed distribution. In a skewed distribution, we get the IQR, which is an interquartile range. That's the Q1 to Q3. Thereafter, we get the upper boundary, that's mean the upper limit of the outliers, and then the lower limit of the outliers. In the upper limit, we have the IQR, that's mean this interquartile range, plus 1.5 times of these, this 75, that's the Q3, plus IQR into 1.5. All right, that's mean whatever the range of these IQR multiplied by 1.5, that would be the upper limit, and then if we subtract from the IQR, then that would be the lower limit. So I'll be showing you these things in the detail. All right, perfect. And we'll be also doing this with the box plot. In the box plot, you get a plot something like this. In the plot, this middle line is the median, and this box is itself IQR, that's the Q1 to Q3 area. All right, that's the interquartile range. Thereafter, you have here the minimum. So this minimum is minus 3 sigma. Median minus 3 sigma. All right, median minus 3 sigma. That's this point. All right, and there you have a plus 3 sigma. That's the maximum data points. And other than that, we assume that those data points are outliers. All right, so this is the box plot. All right, so we'll be doing these things with a step-by-step analysis, but few data points I have already loaded here just for the sake of the simplicity. So these are the 2 cell which I have filled here. We have imported here necessary Python packages, and thereafter we are also importing here this SciPy and the Boston dataset. All right, let's go ahead and run this. Thereafter, once you run it, it will load the Boston dataset from the Scikit-Learn the library. And thereafter, we are gonna call it this load Boston. Then finally, it will load the dataset inside this Boston dataset, and then we are gonna print it. Let's go ahead and run this one. All right, so we have here what we have. We have a Boston dataset, and these are the description. And out of these description, we are gonna use only few data variables, because analyzing all these data variables are gonna take a lot of the time. But just to save the time and give you an idea, I'm gonna just take here a 3 variable. Those variable are average room size per house, and we'll be also taking there the L stat, which is lower status of the population, and the crime. So these data points are actually the outliers. Do you see there? And do you see also here? So later I'll show you how you can find out that exact number which you can assign as a outlier. Alright, so this is the case of the normal distribution. Now let's go ahead and see other one. The other distribution which we are going to plot, there I'm going to plot L stat. Alright, so with the L stat we will see there what is the distribution. And with the L stat, we get a distribution something like this, and clearly we see here it's a it's a left skewed distribution, because the distribution concentration is somewhere at the lower side and it is not at the upper side. And the same thing we see here, the angle of this regression line is more than 45 degree. All right, so there it says that it is a skewed at this end. Thereafter, you see there there is a flat line, and then there is a it's like exponentially increasing, and this should not exponentially increase, but for ideal normal distribution this should be on this linear line. All right, thereafter in the box plot you also see there are some data points which is estimated as the outliers, and this is the case of L stat. And similarly, let's go ahead and get the crime as well. So this crime is actually it's skewed a lot. This crime, this is heavily skewed. The skewness is at the left hand side, and there is completely a flat line, and then there is exponential increase, a sudden increase. There is no outliers in the lower range, but there are many outliers at the upper range. So this quartile, this one is actually saying that, okay, this is the outliers. All right, and you can also see here clearly that there is no the linear relationship, or you can say a linear distribution along with this line. So clearly these are not a distribution, a correct distribution. This is somehow a normal distribution, and these data points are outliers, and these are skewed distribution. These data points are the outliers. All right, now let's go ahead and write a function for the outliers detection. All right, let's go ahead and write it. And for that one, I'm gonna just write here a function, find a normal outliers. All right, thereafter df and the call. So we will actually calculate the outlier detection in normal distribution and skewed distribution separately. All right, so there I have here the upper limit is equal to the data frame and the column for which I want. Thereafter I need to get here a mean, and then there is a plus, and this is going to be the 3 times of the column's standard deviation. All right, that's the STD, and this is for upper limit, and similarly I'm going to do for a lower limit. All right, so there I get it like lower limit, and there is just a minus sign. All right, do you remember here at the start of this lesson I told you that how we are going to calculate? For a normal distribution it's a simple method, and for a skewed distribution it will be a little difficult. All right, so these are the limit. Thereafter I'm gonna just simply return these limits, upper limit, and then I have there a lower limit. Let's go ahead and run this, and then finally I'm gonna say here a find normal distribution for a Boston data set and the RM column. Let's go ahead and run this. It says that at lower we have somewhere around 8, and sorry, this one is the upper limit. Let me just make it like lower and upper like this. All right, so this is the lower limit and this one is upper limit in RM. Let's go ahead and see the RM. This is a room size. It says that if a room size of a particular house is less than 4, though there is no room size which is in a fraction, so we can say that 4 and 8. If a room size is less than 4 for a particular house, then the prediction of accurate house price prediction is a little difficult. And in the same way, if number of room in a house is greater than 8, then that could be also a little difficult to get the correct price. And similarly in the box plot, if you see, that is the somewhere the 4. All right, so this area is the 4. It says that 4.17. These are the outliers, and there is somewhere 8 in the RM. So these are the outliers, that is for RM. And as you know, there after this RM, these L stat and the crime, these are not normal distribution. So if these are not a normal distribution, then we have to write another function for a skewed outliers, skewed distributions. All right, detection, outliers detection in a skewed distribution. All right, so it will be almost the same, but there would be a little the equation there, some equation like this. We need to first get the IQR, that's this one, interquartile range. Thereafter we will be getting these, and then finally we will be doing these analysis. So there are two cases. One is the extreme cases and the normal cases. So what are the extreme and the normal cases? If you see, so these are the left skewed, that's okay, but here this is highly or heavily left skewed. So we'll apply here a extreme case, but here we will apply a normal case, which is 1.5 times of IQR. All right, superb. So this is the find skewed outliers. All right, there you have a skewed outliers, and there we are gonna get here this distance. I'll tell you the distance, explain you. Let's go ahead first get the IRQ, that's the IQR, it's interquartile range. IQR is equal to the data frame, and then you have there a column, and you have here this quantile. All right, so it's like this. There is the quantile, and we are gonna get here the 75%, that's the third quantile, minus the data frame for this particular column, and there is dot, this is going to be the quantile, and this is going to be the 0.25. all right, and once you get this quantile, thereafter we are gonna get the first these 25% of the quantile, and that is for a lower limit, and for the upper limit we will get the 75%. So there you get there for a lower limit, and the 75% for the upper limit. All right, let me show you once again the formula which I want to show you. The formula is like this. So the 75 plus and 25 minus. All right, so there we have here 75 plus 1.5 times, that's the distance actually. So it's like this. I think we can just delete this one. We can put there IQR, and thereafter multiplication of distance. All right, so in a normal skewed we will use 1.5 distance, and in heavily skewed we will use a 3.0 distance, and thereafter the same thing we are gonna do here. Once it is done, we are returning here lower limit and the upper limit. All right, let's go ahead and do this. Find skewed outliers. Once again, we are passing here the Boston dataset, and there L stat. So L stat, this lower status of the population, is not highly skewed. If you see the distribution, it's not heavily skewed, so it's kind of low level of skewness is there. So I'm gonna use here 1.5, and if you do that, it says that it do not have anything like the quantile. Let me see. I think here that should be this quantile actually. All right. Perfect. Now thereafter we get in L stat, if lower status of population, the lower limit is actually negative, so we will ignore this. In the upper limit, lower status of population, if that is above than 32, that we will consider as the outlier. Let's go ahead and see here. That is above than 32, so it's somewhere here. So these are the outliers in case of this L stat, and the similar things we are getting here in the box plot. If you notice these are the outliers. So for the training of machine learning algorithm, if you select these limits and if you train your model where average room size are somewhere in between this, and other than that you should drop all those values. And the similar thing for L stat, In the L stat, if upper limit of L stat is greater than 32, then you should drop those rows. Although you can keep all those rows in the test, but in the training set, you should not do, you should actually first filter out all those outliers. That is in the case of actually the L stat. Let's go ahead and see the similar thing in the crime. All right, so let's go ahead and run this crime. And in the crime, we get almost a similar thing. Since lower limit is negative, so we are going to ignore that. In the upper limit, it's a 10. All right, so okay, one more thing we need to take care. So here we need to pass here a 3 because this crime is actually heavily skewed. So in case of heavy skewness, we should consider a 3. Let me show you where I had explained that here. All right, in case of extreme cases or heavy skewness, we should use that distance is equal to 3. All right, let's go ahead and run this. And thereafter we get here somewhere around 15. So let's see here in a crime of 15. So the 15 is somewhere here. So all those values which are above than the 15, we should drop those while training our machine learning model. And the same thing we are getting here in the box plot. So these values are actually the outliers, and if we train our model on these outliers, so ultimately our model performance is going to deteriorate. All right, so this is all about in this lesson. You have learned how to detect the outliers, how to identify it, and you have also learned how you can predict the how you can get the upper and the lower limit of the outliers. Thereafter, you need to filter out those values which are the outliers. Then you train your machine learning model. And if you do this, then definitely you are going to achieve a better accuracy in your machine learning model. All right, so this is all about in this lesson. Thanks a lot for watching it. Please do not forget to like this video, subscribe this channel, and there is a link in a video description. I would recommend you to watch my previous videos by referring to those links which is in video description. Thanks a lot. Bye bye. Take care.